Hello, everyone. It's good to be back again here. And today we're going to be doing some Docker concepts. Um, I'm hoping that you'll be able to get something cool from this video or this recording that can help you. Either you're starting in Docker or you've never heard about Docker or you're already doing Docker, maybe just a few commands that might come handy for you whilst managing Docker. We're going to just get straight into this. Great. So you can see Docker image, Docker container, Docker file. So from a Docker file, you can create Docker image. From a Docker image, you can spin up containers. That's the concept. Now in scope, we'll be covering around Docker container, Docker networking, Docker volumes, building Docker images from Docker files, and also pushing or shipping over to a container registry. Brief introduction here. Again, the scope of this introduction is just to make us understand where we're coming from. Again, it's not just a concept that's came out of nothing. We had the whole hardware approach prior to virtualization or even prior to containerization. So the hardware is where on the physical host you've got your applications or your servers. The servers, you have applications hosted on them. Then you have to do that physical management, which was never really fun. Those times when you have like load spikes, or probably there could be a denial of service attack and your application would just not survive those kinds of scenarios. So virtualization came in, virtual VMs, multiple VMs can run on a physical host. Then in pretty much recent, we are in that microservices space, which is actually building off the containerization space. Some of the challenges to the prior technology would be resource utilization, scalability, dependency management, isolation, hardware maintenance, flexibility, and cost. I'm not going to delve into each of these in detail, but again, resource utilization was one of the biggest one actually. Then scalability also was the biggest one as well. Into Docker. Now, Docker is a platform. Again, it's a platform that enables developers to build, ship, and run applications quickly and consistently. So, what it looks like locally is definitely what it's going to look like if I'm deploying it in a different environment. That's the concept here. Core of Docker, which we're looking at the containerization technology. That's basically the core, the containerization, allowing multiple applications and their dependencies to be packaged into lightweight, easy to move around, easy to ship, easy to break or destroy, pretty much make changes on the fly super fast. Anywhere you're testing this, either on your local machine as a developer or it's already in the cloud container registry, it's basically the same thing. The Docker engine operates um, on the physical hosts. Now, what we are looking at here is actually a concept called Docker, which is Docker engine, basically responsible for overseeing all the Docker containers on the physical host. In my image here, you can see we've got multiple application libraries, which could be containers in the Docker engine. The Docker we're talking about here. So, see the physical operating system. Unlike in the previous where you have VMs, I could have multiple VMs on the physical hosts, which will be sharing the physical resources. In this concept of containerization, I will be relying on the Docker or the Docker engine to give me that abstraction. Then I can have multiple applications uh, undermining the underlying infrastructure here. So the key components of Docker would be containerization, which is actually one of the critical key components. Containers, Docker containers encapsulates an application and all its dependencies in that isolation. So it's more like in a box. Everything is fit in the box. You pack the box, you seal it, you ship it over. That's what a container looks like. A practical example would be in the shipping industry. You would see ships or these huge ships that can carry multiple containers, ship them from point A and deliver at point B. Again, each of these containers are packed on the deck, and they are stacked up in an orderly manner. Now they are shipped from point A to point B, and they are deployed at point B. Then they are unwrapped, and everything is taken out of it. Basically, the same concept. I can deploy this on my local environment, unwrap it. I would see my application. I can package and ship it to a remote or cloud environment and unwrap it. I'm still going to see my application exactly the same way it is actually at the local end here. Now, the Docker images are actually the building block of containers. So from one image, you deploy containers or multiple containers. Usually they are lightweight, and they should be lightweight actually. The container application code, the runtime libraries, and also dependencies that will be required by the application. We store images in registry like the Docker Hub or the ECR, Elastic Container Registry for AWS. While the Docker file is actually a text file from which we can actually create a Docker image. Now in the text file, we'll have the definitions, which will include stuff like specifying the application requirement, the base image dependencies, and other variables that will be required for that application to actually communicate or work in the deployed environments. Then the container orchestration will be stuff like Kubernetes, which can actually be used to manage multiple containers in a deployed environment. Now, quickly, we'll jump into the hands-on. To install Docker, for those who don't have Docker already, you can actually have this on a Linux, install on a Linux environment. Pretty much, you'd pull this from the package maintainer. If you're using Ubuntu, that will be the app. If you're using Red Hat Enterprise Linux, it would be your Yum or whatever you want to go for that route. Again, you just need to pull from the package maintainer and you have Docker installed, either Docker itself or Docker machine or Docker engine. Then for Mac and Windows, I'll be using Mac today. For Windows or for Mac, you can actually download the Docker desktop. I've got a Docker desktop over here. Currently, I don't have no containers, no image, no volume, no build. And also environment is pretty much empty here. So we'll be using this today. We can also run this off the terminal. So you see, if I clear this Docker version, I've got Docker installed. If I also run this on help, it shows me all the possible commands I could actually use to administer Docker. Either common commands, which would be run exec, ps build, pull, push, version info, or management commands, which would be stuff like to manage networks, to manage plugins, to manage images, to manage all the aspects of the Docker. Then also we can as well see commands to either kill, attach, or detach, or stuff like that, or remove as well, delete. Then there are global commands as well. So I'm going to clear the screen. Now we're going to just get a bit handy into this. I'll put this PowerPoint presentation down. Pretty much not very good at PowerPoint presentations. So, okay, great. Then we'll just get into hands-on. So first thing first, I would pull two images. For one of them, I would rapidly spin a container of the images, or in fact, for both of them, I would do the same. One of them, I would give it a name. The other one, I would give it a name. So I would do Docker run -d. The D here is actually saying interactively or run a container in the background. That's -d. Then put a -t, which is to attach a TTY terminal so I can actually communicate to the container. Then I would just give this first one a name. Then excuse me. Then I will pull from the Alpine image. First, it's going to check if I have this image locally. If I don't have it, as you can see, unable to find locally, it's going to then pull it in from the remote. Then I'm going to do another one, still D, so I can actually interactively spin up a container image from the container from this image. Then I'll do a T, but I won't give this a name. Then I will pull from BusyBox. BusyBox is pretty much a known one. Okay, also check locally if it's not found and pull from remote. Great. Now I've got, ideally I should have two Docker images and two Docker containers, because I use the D flag, which means spin up a container or detach, spin up a container in detach mode. Once you pull the image, spin up a container in detach mode. Okay, let's go looking at Docker desktop. From the container, we can see we've got this container Ben. It is running. Like I did say, I spawn up the container in detach mode. Then I've got this Modus McNulty, whatever that name is, which was randomly generated, I guess, from BusyBox. We can see the images. The first one was from Alpine, second one was from BusyBox. We can also go into the images. We would see both images, and they are both in use. We can see their sizes. I can take actions like run new containers from them, or I can even do check if they are CVEs or stuff like this. Great. Now, if I go into volume, there are no volumes at the moment. Great. We're going to touch on that later. Going back to containers, I can stop or start them. I also have the options, as you can see in the container actions here. If they are CVEs in any of these containers, I can also check them interactively from my Docker desktop. Great. Now we've seen how easy it is to pull images and spin containers from these images. We saw for the first one, we gave it a name. Again, I gave the name Ben. Second one, I didn't give a name, it randomly chose that name for me. I can also check these locally, like Docker images. You would see I've got Alpine and BusyBox, Docker PS. You see I've got two containers. The first one being called Modest, whatever that is, from the BusyBox. Then the second one being Ben, as well, from Alpine. And this first one, I have got an entry point SH. This I've got bin SH. If you do remember, we specified the -T flag, meaning I want to be able to attach a TTY terminal to the container image. That's why you see I can execute commands using the Docker exec on these images. Great. Now we've seen how to list our images using Docker images, list our containers using Docker PS. If I want to list containers, Docker PS shows me that, but I can attach a flag -A to this, which basically will list all listing containers, or basically all the ones that are running and the ones that are not running. Currently, I only have 2 of them here, just so we get that clear. The difference between the -A flag and without the -A flag. I could also use the Docker images or image ls command. Is going to show me the images, but I pretty much love to just do the images, so it shows me all the images. Ls pretty much list all the images as well. Now moving on, we can interact. Remember, I did say the Docker exec command can help us interact with the image, the container that we have spawned. So in this context, we're going to try to interact with some of them using the -it, which pretty much saying open interactive session. That could be an SH or bash or ZSH, depending. In our context, we see for this SH is allowed, bin SH is allowed. So how about we try grab this first one first. I'm going to copy this guy. Then I'm going to do like a Docker exec -interactive. So what I want to do is I'll paste the container image there. Then I'll just put sh start a shell. That's the shell. Now I'm in the container. I'm roots in this first BusyBox container. Basically, anything I'm doing here is no more on my physical host. It's no more on my physical host. You can see pretty much networking is just on the local host because we didn't set up networking for this container. This container will not know how to pretty much ping something like google.com. It basically will be relying the connection from the container to my physical host to reach out to Google. I'm going to cancel this. Great. So we are in a container image. We are no more on my physical host. Now every command I'm executing here is being executed in the container. We're going to try the same thing. Maybe exec, I will exec this. Let's do the second one. Grab the second for the Ben, which was pound up fine. We'll paste this here. Then we'll do like a bash. Okay, we don't have bash, so we'll do a sh. Let me just see something being bash. Okay, it's not there. If I try like an sh, great. I drop in a shell. Also, I will be root. Now, I do not recommend actually this default logging as root on a container image. Not the best option, because if a hacker pretty much is able to gain access to your image by default, they are roots automatically. They don't need to escalate privilege, which is pretty much bad for security. Okay, but that's the situation we have now. Being a security person, I'm quite concerned about this in the very first definition. And also another thing I'll be concerned about, the binaries that we have on this image. Also, we're very much concerned about that. Great. Now we've seen how to start. I could also exec command without actually logging into this image, as I've just shown. I'll exit this. Then I'll just do like a Docker exec. In this context, I'll put a -t. So I would specify my badge, the container name, which is Ben. Then I'm going to run a command ls. Then I'll also do a ps. Basically, you can see I just executed Put a space here. Great. I just executed the command without logging into the container or getting into the container itself. So on the fly, if I'm using the minus t, it is different from when I'm using the minus it. It opens up an interactive session, but with the t, I can just execute a command on the fly. As you can see, that's also working as expected. I could do the same for the other container. Let's just grab that name. Copy this. I could do a docker exec, and I would just do a minus t, put the container ID. Then I'm just going to run a free minus m on this. So it's going to show me memory utilization for that particular container. Great. Now all these are done not opening up an interactive session, but rather just executing these commands into the container that we have open. Now we've also seen that beyond doing this, we can also get into the image itself and execute all into the container itself and execute all these commands. How about we try to start and stop? Let's try to start, stop. Let's try to delete container images. Let's say we remember, sorry, not we do have the image like I showed you, but we also have these containers running off this image. I could pretty much easily do that with the desktop. That's why it's a desktop. Pretty much delete, I'll delete that. But I can also do this here locally. So if I clear the screen, do like a docker, I love to do it right here. Again, I'm not really the big fan of clicking on the desktop app, but again, it's cool to use it. Just like it's pretty cool to use it. I could delete images from here without using this option here. And I usually recommend using what's best for you, either doing the docker ps or docker ps minus a, comparing both of them. It's just the same output. Now I could use the rm with the F flag to force the delete of the container. Usually the container is still running. It's recommended that you stop it before you delete it. But if you don't want to stop it, you just want to delete the stuff, you can use the F flag to delete it. Okay, so we're going to simulate both options here. For this first guy, I will stop it. So let's do a docker stop. Let's stop this guy. Okay, so it might take a while. It's going to send a stop signal. Then once it's stopped, we will try to delete it. Great. Now if I go here, you'd see it's no more running. I have stopped the particular container that was running. Great. Now I'm going to then use the docker rm to remove it. I stopped it, I removed it. Over here it's no longer there, but this guy is still running. So second option, we will just delete this guy or yank this guy out without actually stopping it. So let's grab Ben. I believe that's Ben. Great. So what we're going to do is docker, we'll do rm minus f. Now I'm forcing the deletion of Ben without stopping it. Again, it's gone. But mind you, I still have my images here, so I can start new containers from these images. But just to show you how to stop and delete or yanking it out without actually stopping it, either one you want to work with, cool. How about the option of building a Docker image? So let's say we want to build a Docker image. We have networking as a concern as well. We want to be sure we're able to manage volumes and manage networking for our image. We're going to play into that now, doing that examples or several examples for that. Okay, so speaking about the networking, we will take them one after the other. So the first one we're going to look at is actually the default, which is actually the bridge. Now, Docker provides multiple kinds of networking networks, but the first one we want to consider is the bridge. So let's assume, my bad. Let's assume we want to run an Nginx container with an Nginx image from Docker Hub, pretty much from public, pull that in, and we want to access the web server actually running on Nginx or Nginx web server. So what we're going to do basically here, we'll do like a Docker. Now we're pulling this from remote. If it's locally, We're using Docker pool, but if it's locally, I just want to spin it up. If it's not, I want to pull it from remote. So put a -t, -d. I could also group all this together, by the way, -d. Then we're also going to give it a name. In the name, we'll just put engine X. Then container. Now we're pulling this from remote engine X and the latest. We don't want some vulnerabilities. So it's going to check locally. If it's not there, it's going to pull this in from Nginx. Now this is quite a number, a large image. I could go to my browser. If I can actually open up my browser here. And go to Docker Hub. So we'll just search for Nginx. Great. I'll filter for images. We'll see. I'm pulling the latest. So it's going to grab me the latest. I guess should be these 3 days ago, which was what I just executed. Now, we could see more details here. If we go also into tags, we could see the possible tags in our context of pulling latest. Again, there are all the options here that you could work with. Actually, I'll leave that for you to play with. Now we have pulled Nginx. So if I do a Docker images here, we've got a third image, or a third one called Nginx. Great. Now we see that if I run a Docker ps, there is a container. Remember, we use the D and the T flag, T interactive command line entry point, as you can see here. Then also D, we want to spin up a container from the image. Great. So this Nginx container was found from the Nginx image that we pulled in. If I go back here, there is a third one, and on that container, it is running. Now we also set an entry point for this, so it's actually going to open up the connection on port 80, and we can actually browse our local host on port 80, and we hit that Nginx. I'm gonna grab my magic mouse. Great. So I'm gonna open up this guy here. Then we'll just do 7.0.0.1 on port 80. Just a second, I'm gonna look this up. I'm not sure why I can hit. Probably I have got my firewall. Okay, that's my bad. I didn't expose it out, so it's pretty much in the container image. So what I'm going to do is I'm going to connect to that container. It was my bad, sorry. Docker exec. So we'll do the interactive Nginx. It's actually the Nginx container. I could also use the name. My bad. What's happening here again? Okay, so we'll open up a bash. We are in the container, Nginx container. So if I do like a curl on 127.0.0.1, I should be able to hit Nginx. Again, I didn't expose this Nginx publicly. So in my command, you see I didn't set up networking to actually expose it from the container to my local, which I'm going to touch on later. So that's why I couldn't hit it outside. But in the container, I could see that Nginx is running in the container. That's basically making a call request, and we say welcome to Nginx. Great. Now we can see how to address the first networking issue. Now, if I try to connect this outside as I shown you, I couldn't. But what if I want to be able to allow connection to the exposed to expose it outside? I'm going to exit this. I'm going to clear the screen. Docker ps again, so I can actually see that container image. So I'm going to do like a Docker let me inspect. So we're going into management commands now. Then I'm going to pass the container. Oh goodness, just copy and paste. Great, great. So if we start to inspect this, we would be able to see issues with the not being able to connect to it outside. So let's spend some time digging into it so we can actually address that issue. Then we'll expose it publicly. We'll see how that looks like. So by digging into this, we'll be able to see every bit of detail about that container. If I go all the way to the bottom, the networking settings, like I mentioned, it's using bridge network. Great. If it's using bridge network, we see port 80 is mapped to null, no value there. Great. So we won't be able to connect to this. How about we do something like running a command just to inspect Docker networks. Let's list my badge Docker network ls. We would see that we've got the bridge, we've got the hosts, then we've got the third one, which is none. For the bridge, the driver is the bridge. So how come we have this in scope, but we can't reach it? Let's try to inspect the bridge network. So looking into the bridge network, we'll see the name bridge, created, date, driver bridge, endpoint ID. We can also see a bit of the options. My bad. Let me just drink some water. So inspecting the bridge network, again, we looked at all that config done here. We see EPAM, we see the driver, going all the way to the bottom. Over here, we can see the container, which is our container, is using the bridge network, and it's actually exposed on this IP address. That's pretty much not super cool because this won't be accessible over our own connectivity or our own network. So we need to be able to expose this by doing a bit of port forwarding for us to be able to access that particular Nginx which is running in the container. So the next thing we're going to do is we're going to try and start up another one. I'm going to clear the screen. Then we'll expose we'll do a bit of port forwarding here so we can actually expose 80 to a port outside that we can then reach this. So we'll do like a Docker run -t -d -p. So we're exposing ports. Let's do port 3000. So port 80, which is where Nginx is running, as we saw, as you can see here, we're exposing it to 3000. So we can reach 3000 outside. We'll give it a name. Then we'll use Nginx latest, which we already have locally. Okay, my bad. I'm gonna clear the screen. I pretty much missed something somewhere. Get that fixed and get back. Okay, so we're gonna try this again. I think I messed up somewhere. Oh man, bad command. Docker rim, Docker run. Okay, conflict. So there's already a container running with Nginx container. Great. So how about we do this? We'll give this another name, add an S to it, and we just spawn a new one. Okay, if I go to my here, you see I've got one, which is the old one, and the new one with the S. So for the new one, I'm exposing port 3000, and it gave me a link to just go to my browser and we can see Nginx. Now I can hit Nginx on my machine outside, which is no more in the container itself. Again, I left the first one because I wanted to compare both of them. You would see the difference. For this, there are no port forwarding happening here. Whereas for this, there is a port forwarding. So I'm forwarding 80, which Nginx actually listens on, to 3000. So if I hit 3000 outside, it's forwards me to AT in the container, then it serves me the application in the container. Great. Now we've been able to touch on two or several major things. One, setting up containers, deleting, destroying, taking down. Then also a bit of the first part of the networking. I will try to cover up other aspects of networking before I stop this recording. I don't want it to go beyond 40 minutes. So let's quickly jump into something else. Okay, so first let's do a bit of cleanup quickly. We will delete these. I'm just in here. I already showed you how to do that from the terminal. So if I clear this screen, docker ps, there should be no container running. But if I do the docker images, we should still see our images. So what we're going to do now is we're going to spin two containers from the BusyBox image. Then we'll try to ping both of them inside each other. So we'll connect into both of them, ping them inside each other, and see if we can ping them. Then we will try to make a bit of adjustment on the networking. Again, Docker pretty much creates this concept of isolation. So within Docker, the whole concept is abstraction from the physical device itself. So there should be a bit of networking within containers that such that they can communicate without actually relaying that communication over the physical devices network. Again, from a security standpoint, that's pretty much the way to go. Let's try to create two container images, then try to connect to both of them, then ping both of them and see what it looks like. Okay, so I just split my screen. So on the first screen, we would create a Docker container from BusyBox. We'll give it a name Benny. Then on the second screen, we'll do the same, but we'll give it a name Ben. So if we go here, we should see Benny and Ben. So Benny and Ben are two containers that were created from BusyBox image. Then we will try to connect to Benny and Ben. Then we will try to ping Benny from Ben or Ben from Benny and see if we can actually communicate with each other. Okay, so we're going to connect to the first one being Ben here and spin up a shell. Then we're going to connect to the second one being Benny here and also start a shell. Great. So if I do like an ifconfig here, we would see the first guy being Ben. It's got a .3 here on ETH0, which basically is that bridge. Then we would do the same thing here. And this guy got a .2. Again, they are both on 172.17.0 network. Okay, that's the network mask. So we should be, that's the network ID, sorry. So we should be able to ping. If I ping 172.17.0, which is the network ID, .3 from here, we can reach it. Now, this is the idea. Within the containerized environments, I've got two different containers from the same image. They should be able to communicate with each other. I'm going to just cancel this. Then let's exit both of them. How about we exit and inspect networking? I already shown you, but again, we can use the docker inspect command. If I exit this, and I'm going to grab this container ID and do like a docker inspect on it. If I go to the networking, you would see it got a .3. And if I do the same here, and I grab that container ID, then I do a docker inspect on it, I can also see this guy got a .2. They both have the same default gateway, .1.1. Again, the default gateway, again, because they're in the same network region, I don't really need that communication to be routed through the default gateway, but I basically can actually speak with each other. Again, from a networking standpoint, that's what happens here. Great. Now we can see how easy it is for us to take that abstraction and communicate within the same containerized environment, both of them being able to speak with each other. I'm going to pause and take water. Okay, so let's create a third scenario. So how about we already know that these two guys can speak. How about we create another container from Alpine image, then call it Danny. Then let's try to connect to Danny. I'm going to just grab the okay, so this is Danny. I'll grab this, then docker exec minus it. So we will paste this here and enter a shell. Great. So this is Danny. If I do ifconfig already, you see Danny is got a dot 4 172.17.0.4. Can I ping these other guys from Danny? What would be your answer? Let's try to ping. Let's see this guy. This guy is dot zero. Definitely they are on the same network 172.17.0.2. You can see I can reach it now. The idea behind this is we already established that this is bridge network. Every container created from an image definitely would take up a network address within the bridge network. Hence, they should all be able to communicate. Yes, that could pose a security concern, but again, the whole concept of containerization here is to create an abstraction. Can we actually abstract each of these so they don't speak? Obviously, yes, we can do that. As we advance, we'll be able to look at how that works as well. But so far, if we're relying on the default bridge, you should know that they will all be able to speak with each other. If you're comfy or comfortable with that, it's the way to go. But let's take it a step further. Okay, now one more thing to add before I move on. What would be one of the biggest limitation or biggest struggle to using the bridge network would be the DNS resolution. So again, I know this guy is Danny. If I try to ping this guy by his IP address, which is 172.17.0.4, I can. But what if I try to ping this guy by his name, Danny? Obviously I cannot. Bad address. Now this is because for the default bridge I cannot do DNS resolution. That's a big limitation. So if I'm considering using default bridge for my containerized application deployment, I should know that there is a limitation of DNS resolution. Hence, if I'm relying on DNS resolution for the connection between each container, that would be a limitation if I'm doing default bridge. Again, this can be overcome using another networking option, which we're going to look at briefly. Okay, I'm guessing this video will extend on all the way to 50 minutes. I hope that's not a problem. I will split it into two parts. So this first part, I'm going to cover everything we've touched on and the three kinds of network, which would be the first one, we saw the bridge, the second one, the user defined, and then also the host one, which would be the third one. Quick caveat. Now, for the default bridge network, like I mentioned, it does not provide internal DNS resolution, no DNS name resolution for the default one. They also will not use the host network, so they will not be isolated. Again, you should keep that in mind. They will use the host network, sorry, I mean, because they use the host network, they are not isolated. So I can actually reach ping outside and outside can ping back into me. Great. Now let's talk about the second network, which would be the user defined bridge network. So it's in the bridge network. The user defined bridge network is the second one. First thing first, we're going to just clear all the screen. I'm going to exit this, exit this, and exit this. So remember, we still have our three containers, or I think it's three. Yeah, three of no, more than three now. I think yeah, three of them running. We also still have our three images. So let's create a network. Remember when we ran the command docker networks to see the network, we actually saw that we are using the bridge. So if we do like a docker network, great, we're creating a new one. Let's just give it a name. We'll call this Zilly network. Okay, that's Blesley. Okay, great. Cool. Now we have our network created. Then we're going to create a container image from this and actually use this network, attach this network to the image the container, then attach this network to the container we're going to create. We're going to see how that works. Okay, so quickly, if I do like a Docker, just see network ls. My bad. Uh, okay, we see we've got the bridge, we've got the hosts, then we've got the Zilli network. Now, this is the user I did mention again. This is still kind of a bridge network, but it's user defined bridge network. So it's still classified under the bridge driver, but we are creating this network. So let's try and start some containers and use this network. So Docker run ITD. Great. So we're attaching the D to this now. The network, we're going to specify the network we just created. So it's actually Zilli network. I'm going to copy this and paste this here. Then we'll give it a name. We'll just call it Nginx on. Then we're going to just use the Nginx image, which we have. Great. If I go over here, we should see a new container, Nginx con from the Nginx image. Again, we have Nginx image present here. Now we're going to do like a Docker PS here just to show the same thing. We would see my bad, Nginx con port 80. Remember, this is still the Nginx application, so we will assume that we can actually reach this from outside. Now, is that assumption true? We're going to do a bit of verification just to check that. Let's do a Docker on here. Inspect. Docker inspect. Let's inspect our network. My bad, I didn't realize I highlighted that. Copy this. Great. Now we would see that our container has taken up something from 172, no more 17, 172, 18. Now this is different. If I try to, let's say we fall back here, and or let's just fall back here. Let's connect into this guy. And remember, this guy has 172.17. Then let's try to connect into this guy we just created. Let's do a Docker. So we're going to grab the container ID. Then we're going to start a shell in here. Okay, it's not present. Do I have ping? No ping. Okay, funny. But we can see it's got a .2 here. So let's try to. We've got ping here. Ping 172.18.2. We cannot reach it. Again, at this point, we can see that this belongs to this network group, which differ from the network group this guy belonged to. This is bridge default, but this is user bridge. So I cannot directly reach both of them. Again, it's important to actually note that. For that limitation, I can't actually reach both of them. But if I'm going to just give me a second, cancel this. Over here, I'm going to do like a Docker inspects. Let's just inspect the network we created, which is actually Zilli. What's the name? Zilli network. Oh, exit. My bad. Great. So again, it's important. I think it's the same command I actually executed here. It's important to note that this guy belongs to a different network than this guy. So I cannot reach both of them. Now, I did mention that you can still create an isolation or abstraction in such a way that you've got these containers all created from the same image, but not being able to communicate. Again, remember these initial ones, if I go back here, they were created from image busybox. How about we try to do the same thing? Let's create another one from the image busybox, then assign it to a different network and see if they can actually communicate. So we're going to try to create from busybox. I just created a new container from busybox. So if I do docker ps, I can see I've got a new one, which is busybox con. I'm going to grab this ID, then I'm going to connect to that guy. I'm just going to clean this up and paste this here, then connect to it. Okay, so I'm going to connect back to this other guy. I have config, or I cannot actually, but I do know the network address of this guy, like I showed earlier, which is the let's go back to our containers. So the new one I just created is actually the one from busybox, which is busybox con. Then nginx is the other one. Now both of them, if we look at both of them, let's do like inspect on both of them. I'm going to use this page, docker ps. So we're going to run a docker inspect on this busybox con and the nginx con. We would see that both of them should actually be on kind of like the same, because again, both of them I'd used the same network to create both of them. So let's start with the first one. I'm going to copy this and do a docker inspect on this guy. Go over to the network. We see this DNS busybox con. I can actually do a DNS resolution on this guy. And very important, the network is the Zili network. Then very important to note that I'm going to also do the same. I will run that first docker ps, then I will run that on this as well and inspect this guy. Again, this can do a DNS resolution, and this also belongs to the Zili network. So it means I should be able to, this is the nginx con. I should be able to, I connected here, docker ps, second exec it 64 is Danny. Oh, my bad. Okay, so I should be able to reach the, give me a second. I should be able to reach both of them, should be able to ping each other, because again, they belong to the same network. I'm going to just exit this, be sure I'm connecting to the right thing, exit this. Then I'm going to clear the screen and clear the screen. Okay, so let's docker exec. I want to connect to this guy first. I'm going to clear this, paste this here. Then I'm going to connect to this guy also. Docker exec. Paste this here. Great. I think there should be if config on this, not on this. On this. Great. So this is on 18.3. Very important. Now, if we can find out the IP address of this guy, which we obviously can do, this is 2A. So 2A, we'll copy this. We'll do a docker inspect on this. Then we would see the IP address is 18.0.2. Now, this guy has ping. If I ping 172.18.0.2, I should be able to reach it because they both belong to the same network. Remember, they're both using the Zilly network like I showed. And I can also do like cancel this. And this guy is I'm gonna do a quick verification again. I'm not sure I remember what he is. Docker PS. So this is the 2A. This is the Nginx con. Let's ping using the name resolution, and you can also see that I can actually resolve that name because again there is DNS resolution happening for both of them. Now, why would I want to go through this hurdle? We can basically want to have multiple containers belonging to the same within the same physical host, but being able to abstract the networking where I can have 3 or 4 of them communicating with each other, but completely isolated from all the other ones. And this is one way we can do that. User-defined bridge network can give us that opportunity because it allows DNS resolution as compared to normal bridge network, default bridge, which doesn't allow DNS resolution, as we've seen via the demo. Great. A few more things to consider would be to note that again, I won't be able to reach this outside or before unless I actually do the port forwarding. So I still have to do port forwarding for this. It's not like I'm just going to be able to reach this Nginx from outside off the fly without doing port forwarding. For me to reach this outside, I must still port forward. Very critical to know that. So we've addressed one critical challenge with the default bridge, which is DNS resolution. I can do DNS resolution. I can create multiple new networks. I can have containers within those networks completely isolated from the other ones. Then I can do DNS resolution. Perfect. But we're still not addressing that issue of connecting outside unless we actually port forward. Now, the third network would be the host network. So again, if I run the command, I'm going to exit this Docker. We see we've got the hosts here, which is the third option. I'm going to pretty much delete all these layers. Great. How about we want to take advantage of the host network? So we're going to demo something. I'm going to exit this. And I'm going to do like a Docker quickly run. I'm almost out of time. Minus TD here. Again, if you're wondering what these flags are, I've already explained them in the past. Network. So for this, I'll use the hosts. I'm not using the one I created. Then I'll give this a name. Let's just call this Nginx server. Again, so I can completely differentiate it. And I'm going to use the image Nginx latest. Okay, great. If I run this and do a Docker ts, I should have one more. It's easy to view from here. If I just go to containers, I will see Nginx server, and I have Nginx server up and running. Now, this will run Nginx container in the host network itself. Remember, if you try to reach the Nginx server from localhost, it will work. Is this a recommended approach? I do not think so. Because again, what's the whole point of containerization if I can just expose anything out like that? From a security context, I do not think it's the best way to go for this. If I do like my 127.0.0.1, my bad. Did I expose on port 80? I think I did. I'm going to just quickly check this again. 1 second. Let's quickly do a bit of investigation as to why I wasn't able to reach this. I'm going to clear the screen. I'll do a Docker ps here. It's the first one, I believe. Let me see. Oh, my bad. I think I know why I wasn't able to reach it. Okay, great. I didn't really much expose that port 80. We can see that I didn't address the issue of the entry point. So if I go to, which is this one, I do not have a port exposed for it, but I'm just going to copy this and I will run a command docker inspect nginx server. Then I'm going to grab IP address. Okay, you see it's a null value, so I don't have an IP address assigned to this. Basically, that's why I couldn't even reach it. Again, by default, it's supposed to actually get one, but if you didn't get one, definitely you run into problems like this. If it doesn't have an IP address, it should be able to use our host's IP address. Let's try something. Let me do ifconfig here and try to, but again, it should be able to. This is the bridge network. Let's grab 192. Let's grab this guy. Let's see. I'm just going to try to resolve. It should be able to actually reach that server running. But again, I could go on and on with networking. There's still a whole lot to cover in networking, but I'm going to have to stop this video here. We could do, before I stop the video, I could just grab this and do like a Docker on this. Go over to the networking settings. We see there is no value here for bridge. Very important. We null IPv6 null, IPv4 null. Again, those values were not populated, so by default it should have used my own IP address. See, it's pretty much taking time to actually resolve. Funny enough, should be able to resolve. But anyways, I'm going to stop this recording here. Now we've covered 3 different types of networking, which is the default bridge, then the user-defined bridge, then as well as the host network. Are these the only networks available to Docker? No, there are other types of networks. I have to clearly state this at this point, but I could go on and on again. It's never going to end. I'm already 56 minutes in. I want to stop this recording here. There will be another recording where I'll cover volumes. We'll be looking at bind, mount, Docker volumes, and also how to use Docker volumes. Then also we'll see an example of containers with a bind mount. Then as well as we'll do a bit more talking around a few more concepts that are of importance, which would be mounts, how to mount the mount, and also containers with volume in detail context. I hope you like the content. If you do, please like, subscribe, then also do not forget to turn on the notification so you can always receive notifications when we have good videos out there. So what I'm going to do at this point is I'm going to quickly clean up. It's easy for me to clean up here. I can just delete all the containers that I've got created to free up space. Okay, I will leave the images running. I'm just deleting the containers. We did not create any volume yet, so I don't have to bother about that. The images, I'll just leave the 3 of them. For the next recording, I would use them to talk about volumes and also mounts. Thank you for your time, and I do hope to see you in the next recording. Have a good one.